Okay, welcome students to the part 3 of this chapter 2. Here we'll discuss with the number 2. Find the zero of each of the following quadratic polynomial and verify the relationship between the zero and their coefficients. Okay, it's given that the equation is 7x squared plus 7x by 2 plus 3 by 4. What is A here? A is the coefficient of x, which is 2. B is coefficient of x squared, which is 7 by 2, and C is 3 by 4. Okay, remember A is 2, B is 7 by 2, and C is 3 by 4. We have to verify. After finding this zero, we have to verify the relationship between this zero and the coefficient. Okay, now let Px be the given polynomial 2x squared plus 7x by 2 plus 3 by 4. For finding the zero, this polynomial should be equal to 0. Okay, for finding the zero, this given polynomial should be equal to 0. That means 2x squared plus 7x by 2 plus 3 by 4 should be equal to 0. To simplify this, we will multiply throughout the equation by the coefficient of the LCM of denominator, which is 2 and 4. The LCM of 2 and 4 is 4, isn't it? Therefore, we'll multiply throughout the equation by 4. What we'll get? 2 multiplied by 4 will get 8. 7 by 2 multiplied with 4 will get how much? You'll get 14, isn't it? Because 4 and 2 you cancel, we go 2, 2, 7, give us 14. Then 3 by 4 multiply with 4, 4 get cancelled, we'll get only 3. On the right side 0, if you multiply by 4 you will get 0 itself. Clear? Now we have to split the middle term of this quadratic equation. Which is the middle term here? Is 14. How will split this middle term? By multiplying the first term, that is the coefficient of x squared, with the constant 8 multiply 3. Here I've shown you on the right side. 8 multiply 3 is 24. The factor of 24 are 2 12 are 24. Okay, we'll stop here. Why? Because we need 14. 2 plus 12 give us 14, isn't it? Therefore, instead of 14, which is the middle term, we can write as 12 plus 2. 12 plus 2 is 14, isn't it? Now you multiply this x to 12, you will give us 12x. 2 multiply with x, 2x. We have altogether 4 terms now. You take common between first and second, the third and the fourth. Between the first and the second, 8 and 12, which is a common factor? 4 is common factor, because 4 2s are 8, 4 3s are 12. And x is also common, therefore taking common 4x, will have within bracket 2x plus 3. Then plus, between the last two terms, neither 2, 3 nor x is common, therefore we'll take 1 as the common term. Within bracket you will get the same thing, 2x plus 3. Now this 2x plus 3 and 2x plus 3 is the same. You'll write as 4x plus 1, 2x plus 3 equal to 0. Now the product of these two should be is equal to 0. That means either of these two should be equal to 0. Either 4x plus 1 should be equal to 0, or 2x plus 3 should be equal to 0. Now taking this constant to right side from both of these terms, plus 1 take right side will give minus 1, plus 3 will give minus 3. Hence x will be minus 1 by 4. From the second part, x will be minus 3 by 2. This means we have found out the zero of this given polynomial to be, the first zero is minus 1 by 4 and second is minus 3 by 2. Let us take alpha minus 1 by 4, beta by minus 3 by 2. Okay, let us find out the sum of the zero. Sum of 0, alpha plus beta, that is minus 1 by 4 plus minus 3 by 2. Plus minus is minus. Okay, LCM of 4 and 2 is 4. 4 divided by 4 is 1, 1 multiply -1 is -1. Here we have minus 4 divided by 2 is 2, 2 multiply 3 is 6. -1 minus 6 will give us -7 by 4. Now this -7 by 4 is having in this form minus b by a or not. Let us check. What is a? A is 2, b is 7 by 2. Minus b by a mean minus of 7 by 2 by 2. 7 by 2, you change this division sign to multiplication sign. 2 you can write as 1 by 2, that is 7 by 4, which is having in the form of minus b by a, that is the quotient of x by the quotient of x squared. Clear? Let us check with the product of 0. Product of 0, alpha multiply beta, that is -1 by 4 multiplied with -3 by 2. Minus plus 3 multiply 1 is 3, 4 multiply 2 is 8. Now 8 by 3 we are getting the product. Now is this 8 by 3 is having in the form c by a? Let us check. A is 2, c is 3 by 4. Now c by a mean 3 by 4 divided by 2. You change this division sign into multiplication. 3 by 4 multiply 1 by 2 will give us 3 by 8. That means this 3 by 8 is having in the form c by a. Clear? Which is a constant term by the quotient of x squared. Hence, this also we have verified that the product of 0 is equal to c by a. Clear? Next, we go to the problem 2. X squared plus 3 by 2 root 5 x minus 5. Okay, this is the given problem. We have to find out the 0, and then after finding the 0 we'll verify whether the sum of 0 and product of 0 is equal to minus b by a and c by a or not. Okay, now in this given polynomial, what is a? A is quotient of x squared, which is 1. What is b? B is quotient of x, which is 3 by 2 root 5, and c constant term, which is minus 5. Now for this given polynomial, for finding out the 0, we have to take for px equals 0. That means x squared plus 3 by 2 root 5x minus 5 should be equal to 0. Here, to simplify this, we will multiply with the denominator throughout the equation by 2. 2 multiply x squared to x squared. 3 by 2 root 5x multiplied by 2. 2 will get cancelled. We have on 3 root 5x. 5 multiplied with 2 will get 10. Okay. Now here we have to split the middle term. What is the middle term here? 3 root 5. Okay. How will you split it? You multiply the quotient of x squared with constant. 2 multiply 10. I have shown you on the right side. 2 multiply 10 is 20. Now the factor of 20 you can simply write as 4 multiply 5 is 20, isn't it? You need 3 root 5 in the middle as a middle term. 3 root 5 is there. Now from 4 and 5, can you get 3 root 5? Let us see. Now root 5 can be written as 4 multiply 5 can be written as 4 multiply root 5 multiply root 5. Clear? Because root 5 multiply root 5, you'll get root 5 squared, which is 5 only, isn't it? Now from this factor, one will take 4 root 5, the other will take root 5. Now if you take 4 root 5 minus root 5, how much you will getting? You will get 3 root 5, isn't it? Therefore, instead of this 3 root 5, you will substitute by these two, 4 root 5 minus root 5. Okay, we are substituting 3 root 5 by this term 4 root 5 minus by root 5. Okay, the next step we will multiply this x to this term which is in bracket. 4 root 5 multiply with x, 4 root 5x, plus with minus look carefully for the sign also. Plus with minus is minus, root 5 multiply x is root 5x minus, and this 10. Then we have to again split this 10, so that because here we have root 5, you have root 5 which is common, between this root 5 and 10. If you simply write 10, root 5 and 10, mean it will be difficult for you to identify which is the common term. Therefore, instead of writing 10, we can write as 2 root 5 root 5. Because why? 2 multiply root 5 mean 2 multiply 5 with this 10 itself, isn't it? Therefore, instead of 10, we can write 2 multiply 5 root 5, but 5 we will split it as root 5 root 5. Now, why we are doing this? To make us easy to identify the common term. Let us take between the first and second term, which is common. 2 is common, x is also common. Therefore, taking common 2x, you'll have x plus 2 root 5. Okay, then minus. Between the third and the fourth, root 5 is common, isn't it? Root 5 is here, root 5 also here. Taking root 5 common, you'll have x. Then sign will be how much? It will not be this minus, because minus with this minus will change to plus. Whenever we are taking common with minus, this minus you have to multiply. Minus with minus will give us plus. Therefore, what will be remaining after taking common? Root 5 has been taken common. You will have only 2 root 5. It is equal to 0. Now x plus 2 root 5, x plus 2 root 5 is the same, isn't it? That means the process of taking common that we have done is correct. Hence, the next step will write as 2x minus root 5, and x plus 2 root 5 will take only once, which is equal to 0. That means either 2x minus root 5 should equal 0, or x plus 2 root 5 is equal to 0. Transposing this root 5 to right, 2x equal root 5, x equal minus 2 root 5, x equal root 5 by 2, x equal minus 2 root 5. Now we have got the zeros of this given polynomial as root 5 by 2 and minus 2 root 5. Taking alpha by the first 0, beta by the second 0, let us find the sum and product of 0 for this given polynomial. Okay, now the sum of 0 will be alpha plus beta, 5 root 2 plus with beta, which is minus 2 root 5. Plus minus is minus, isn't it? Now taking the LCM of here below 2 root 5, there is 1. 2 and 1 LCM is 2. 2 divided 2 is 1. 1 multiplied by 5 is 5. Then this LCM divided by 1 here with s in the enter. 2 divided by 1 is 2. 2 multiplied with 2 root 5 will get 4 root 5. Now 4 root 5 minus by root 5 will get 3 root 5, isn't it? Minus sign will be greater. Therefore minus 3 root 5 by 2. Okay, now minus 3 root 5 by 2 is having in this form minus b by a. Yes or no? What is a? A is 1. What is b? B is 3 by 2 root 5. We have taken earlier, isn't it? What is a and b? Now here a is 1, b is 3 by 2 root 5. Now minus b by a is equal minus 3 root 5 by 2 or not? Yes, minus b by a is 1. Minus 3 root 5 by 2 multiply, changes division sign to multiplication sign. 1 will be 1 itself. It will be minus 3 root 5 by 2, which is in the form minus b by a. Hence, verify. Clear? That is minus b by a. What is minus b? Coefficient of x by coefficient of x square. Now let us see with the product. Product alpha beta. Alpha is root 5 by 2. And beta is minus 2 root 5. Cancelling 2 with 2, you'll get root 5 multiply root 5 minus of root 5 square, which is minus 5. Now minus 5 we can write as minus 5 by 1, that is c by a, isn't it? With this constant term by quotient of x square. Hence here also we have verified that the product, the sum and product of 0 is equal to the quotient of x square by quotient of x by quotient of x square in the sum, and product by constant by quotient of x square. Clear? Okay, we have come to the end of this part 3. On the next class we shall discuss with the part 4 of this chapter 2. Okay, bye to all of you.